I am the Tofu Golem. Please enjoy the video.
You start now by prioritizing safety. Disconnect power and remove the battery if you can. Use gloves and goggles. Live cells can be dangerous. Next, visually inspect terminals for corrosion, swelling, or punctures and note any leakage. Once done, set your multimeter to DC volts and test across terminals to confirm voltage level, because voltage guides the next steps, charging, conditioning, or replacement, and prevents wasted effort on a dead or unsafe cell. You now perform diagnostic measurements to determine the true condition. First, measure open circuit voltage, and then apply a known load to record underload voltage drop. Large drops reveal high internal resistance. Use a battery analyzer to log internal resistance or approximate it with a multimeter and known resistor. Compare those numbers to the manufacturer's specs so you know why failure occurred. Once you quantify deviation in percent, you can decide: recharge, perform conditioning cycles, or proceed to safe replacement. You implement the fix. If diagnostics allow, use the correct charging protocol, constant current then constant voltage, or the manufacturer method. Begin slow charging and perform 2 to 3 conditioning cycles, monitoring temperature, voltage, and current closely. Stop immediately if temperature rises unexpectedly. Once conditioned, run a final load test to verify capacity. If the battery delivers less than 80% of spec, replace it and dispose of the old cell per local hazardous waste rules. One key troubleshooting tip:
Thanks for watching. Consider subscribing if we helped you today.